We start. Okay. 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 Everyone is ready to pay attention? Yes or no? Okay, good. Look at that. This question, perfect. This question is easy, but it's a little bit tricky. The question say, I want to read in the paper. Determine the interval over the function is decreasing, increasing, and constant. And write your answer in interval notation. Let me explain in detail. And in the lecture, we have no time to explain this, but it's extremely easy. Look at that. Okay, suppose that we have two values of the x. x2 is greater than x1. And this implies that f in x2, que is the y value, is greater than f in x1. When this situation happens, this function is increasing. Otherwise, when the f of x in x2 is less than f in x1, it's decreasing. Decreasing. And when it's equal, it's constant. In a specific interval. When it's equal, it's constant. In a specific interval. So it's super easy to determine that because we suppose that the curve look like a roller coaster. And we travel roller coaster car on the curve. That always from left to right. This is confusing. I understand that. Okay. The motion of the roller coaster car travel from left to right always, never backward. And this arrow is confusing because this arrow, the only thing que indicate this arrow is que this curve continue forever in that direction. So it's like that. Fuácata, 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 fuácata. Entonces, this, no, the student believe que this is a motion. No, it's no motion. It's just que this curve continue forever in that direction. But to analyze increasing, decreasing, or constant, you travel on the curve using the roller coaster car. And you travel always mandatory from left to right. Therefore, I want to highlight in green color. Look at that. In green color, I can see that in this interval, it is from negative infinity to 0. Okay, the function is increasing. Entonces, another confusing thing is que the interval que we expressed, so the answer que you offer is expressed using domain value, because domain is the most important set in the function, no? X value. Entonces, the curve give you, for example, X and Y to confuse you, but you don't care. You only focus it. Sorry, professor, it took me white. Sorry, professor, I took me. I don't understand. Activate the microphone. What's the problem? Okay, look. The important is increase.
It took me a little bit to get in.
Say again?
That it took me a little bit to get in.
Okay. So increasing. Increasing is from, in the question 1, no? From negative infinity to 0. Of course, do not include 0 because 0 is the transition point in which change the behavior. In the first part, the function increases, but in the second, decreasing. Because the roller coaster is going down. Entonces, this decreasing is from 0 to positive infinity. And constant, never stay in the same height, the roller coaster car. Okay, entonces now, let me try using another color. For example, the green color, and that part, the function is increasing. And the yellow part is decreasing. Yellow part decreasing. And the green part is increasing. Any question, guys? Do you understand this or no? Yes or no? Answer me. Did you get the idea? Aha, very good, Sabrina. Sabrina say, I got it. Everyone got it? Sure? Okay. Let me try the second example. The second example is similar. We travel from left to right. So we go from negative infinity to positive infinity in the domain, que es a real number, right? And the roller coaster car is going down in this interval. So basically, decreasing is decreasing, no? Decreasing is yellow here, yellow here. And the negative 0.5, no, start increasing. Look, the roller coaster car is going up. Entonces es increasing. Look, increasing in this interval. Okay. Now, finally, in the last interval, the roller coaster car is going down also, and the function is decreasing. Entonces, what is the conclusion? The conclusion is increasing, column, decreasing, column, constant, column. Increasing is from negative 0.5, comma, positive 0.5. Of course, do not include the endpoint because in the endpoint we change the behavior. No. And decreasing is in two pieces. And the yellow part is from negative infinity, comma, negative 0.5, union, because it's two intervals separately, 0.5, comma, positive infinity. And in the constant, never. Any question? Super easy. Let me read again. Determine the interval over the function is decreasing, increasing, and constant. Write your answer in interval notation. So I want the answer in that way, guys. Interval notation. Interval notation, remember, is the way in which you put, using parentheses or square bracket, you put a lower bound separated by a comma, the upper, que specificate the interval. For example, in this interval, we go to the negative 0.5 to positive 0.5, lower, and this order, upper. Si you switch the order, it's incorrect. Any question? Super clear? No? Understand or no? Understood or no? Okay. Now let's move on to number three. Number three. No, number two. Number two, I did that. Number three is a piecewise function, and the piecewise function is defined in this symbolic way. You open the big curly bracket. Entonces es 3 expression minus 3x plus 2 if x is less than negative 2. And the expression is x squared plus 1 if x is in between negative 2 and positive 3. And yes, just for it's a constant function if x is greater than or equal 3. Entonces específica en el test, I want que you evaluate this piecewise function in different value. For example, evaluate negative 2, evaluate negative 3, evaluate 0, evaluate 5, evaluate 3, and evaluate negative 4. Okay, let's start for the first one. Negative 2, negative 2, negative 2. Negative 2 is a complicated guy because negative 2 belongs to the first or to the second. Okay, negative 2 is here. Negative 2 belong to the first expression or the second? What do you think? First or second? No idea? You know or you don't know? Come on, answer me. Sabrina is, I don't know. Sabrina is easy. Look at that. Look at that. You plugging in -2 here. -2. -2 is less than -2. This statement is true or false? Es obvio que es false, right? Es obvio que es false. However, so you plug in here, -2, less than or equal, -2, this statement is true. Okay, entonces, in one easy way, when you see equal sign, belong to this. Equal sign belong, no equal sign do not belong. So -2, where is located -2? Equal, no less than or greater than, no, hello, equal. In the second expression. Do you see or no? I need to know if you see or no. Okay, now you evaluate, you selection the second expression, que es x squared plus 1, and you evaluate at -2. Entonces, -2 plugging in here, square plus 1. Be careful with the sign. -2 squared is 4 plus 1 is 5. End the story. The first problem is 5. The second, -3. -3 is located in what interval? In the first, in the second, or in the third? What do you think? -3, -3, -3. -3. Guys, come on, participation. No idea. In the first one, it's obvious. Because -3, when you plug in it mentally, less than -2, this statement is true. So you select the first one. And the first one is -3x plus 2 is expression, and you evaluate at -3. Be careful with the sign. We have -3, que is the coefficient, x is -3, double minus, become positive. 3 times 3 is 9, positive plus 1 is 10. And this is my second answer. Okay, super. What about 0? 0 belongs to the first expression. Second is not plus 2. Plus 2, plus 2, plus 2, plus 2, plus 2. Yeah, all right. Thank you. It's 11 then. It's plus 2. It's plus 2. Thank you. 0. 0 belong to the first, belong to the second, or belong to the third? First, second, or third? Remember, this is the only thing you should do is understand in what interval lies 0, and selection the expression que corresponde with this interval, no? Okay? Number 1, number 2, number 3. Guy, do you follow me or no? This is a review. This is important. We see before this part. However, we are doing review to refresh your mind. Okay? Reinforcing the concept. Do you follow me or no? Come on. I need to know. Come on, Caroline. Hannah. Okay, I am following. Okay. Pero entonces answer me, please. Okay. Yulisa, it's okay. Yaneli. Okay, entonces what interval belongs 0? In the first, in the second, or in the third? 1, 2, 3. Come on, answer me. 0. Third one? No, Sabrina, no. The second one, you're right. You're right. Look at that, 0. Okay, well, listen to me. One, a representation to understand much better. This is my x value. This is the domain. We have here 0 in the middle. This is infinity positive, this is infinity negative. Okay. So we have transition point, -1, -2, -2, -2. Before -2, less than -2, is valid this expression. -3x plus 2. Here, this expression is valid in this interval, in the blue interval. No include -2, because I don't see equal sign. And between negative 2 and positive 3, 1, 2, 3, is valid. Let me use some green color, bracket here, and parenthesis here, the expression x squared plus 1 is valid in this interval. And after 3, include 3, of course, let me use in yellow color, bracket to infinity. Entonces, this expression that I'm using is just 4. It's a constant function, do not depending on x. Entonces, now it's clear to understand. When you try to evaluate at 0, 0 is here. And belong to the interval green. And associated with the green is expression x squared plus 1. Do you follow me or no? And you evaluate at 0. The process is easy. The process is identification and what interval lie my value after selection, the expression que corresponde in this interval. And finally, plugging in. That's a 0 squared plus 1 is just 1. 5. What do you think about 5? 5 here. 5 corresponding with the yellow interval. Yellow is, let me associate here, yellow is this interval. Green is this interval. And blue is this interval. And so we can 5 belong to the yellow part. And the yellow part is just 4. The answer is 4, without. Because it's a constant function, the expression do not depending on x. It's just constant, it's 4 in the story. Okay, and 3. What about 3? 3 belong to the blue, green, or yellow? No,
Yellow.
Sir. Yellow, of course, because look, it's important. The detail is important in this case. Equal sign here, equal sign, no equal sign here. Now, 3 is the transition guy, que is confusing. I understand, que belong to the yellow because it's equal. Equal sign is the most important information in the transition point. And the connection to interval, you need to be careful with the equal sign. Entonces es obvio que belong to the yellow, que yellow is 4. And that's it. And negative 4, bueno, negative 4 is negative 3, negative 4 belong to the blue, and the expression associated with the blue is minus 3, x plus 2, evaluate at negative 4. Entonces negative 3 times negative 4 plus 2, this is 12 plus 2, 14. Any question? Any question? You feel strong now? Eh? You feel good or no? Come on. Good. I understand it more now. Okay. The problem, Sabrina, is that you don't forget. Okay. This is the idea for the when you study in college and university. You understand, but you forgot, you are doing nothing. Okay, number 4 is similar, but number 4 is graphically. Do the graph of the piecewise functions. And the test, guys, the test is very, very similar to the review package, right? So you understand the review package, you pass successfully the test. No secret, everything is clear. Of course, different number, but the same objective. Okay, what is the idea? The idea is do the graph. Do the graph of this piecewise function. Okay? So I focus it expression by expression. I take this. But this is y equal minus 3 plus x. Or y equal x minus 3. It's the same, no? But I write in different way because I realize it's a linear function, it's a line. And the equation of the line, everyone remember is the mx plus b, no? B is 3, does that mean que the Y-Intercept is -3, -1, -2, -3 here. At the point 0, -3. And the slope is M, is the coefficient in the front is 1. The slope is 1. Remember the definition for the slope is wrong and rise. I suppose it's 1 is wrong and rise is 1. It's a coincidence, it's 1, 1. 1 up because it's positive and 1 to the right. We get the second point and we connect in this point by the line. I put the other line because this is not the final answer. It's a partial answer. Everyone follow me and do the line or no, or it's complicated this? Sure? Everything okay so far? Yes, Sabrina. Sabrina always help me. Okay, let's move on to the second expression. And the second expression is y equals 4. And y equals 4 represent the horizontal line. 1, 2, 3, 4. Again, dotted line because this is not the final answer. Okay. This is it. So the thinking we are doing so far is do the graph of the first part and the second part. But this is not the final answer. The final answer is the combination like a piecewise function. Therefore, it's extremely important the transition point is in 1. I'm using another color. Transition point is in 1 here. In 1, we have a dotted line, like a vertical line, can split the plane into parts. This is 1. X equal 1. Before 1 is less than, is valid the expression 1, que es a line, the oblique line. And after the 1, que is to the right, is valid the constant function, que es y equals 4, que es the horizontal line. Therefore, my graph look like that. Here, I don't know, I put a circle, I put another circle, yeah, I continue forever in this case. Okay, the green is the graph of the piecewise function. So let me repeat again. Before 1, less than 1, is valid the expression number 1. And the expression number 1, I did the graph, is a curve, it's a line, so it's a line, it's an oblique line. And 1 is stop, no more travel for this line, and jump to the horizontal line. Entonces, the last detail, we have 2 circles, bam, bam, bam. 1 is open, 1 is closed, in general. So how you determine what is closed and what is open? Equal sign. Equal sign indicate us that this is closed and this is open. Okay, and we can delete, we can erase everything because my final answer is just the green part. Any question? Any question? No? Crystal clear? One similar of this, you can see in the test. 2-piece, no 3-piece, of course. And normally it's easy function, lines, it's a linear function or constant function. No super complicated. So I can you another one? No. See, we have time, yes, but we need to move on to another topic, no? Okay, and the Alex, we have a lot of problem of this, and you have some question, you let me know by email, okay? See, we have time. Remember, today is a review. Next Monday is a continuation of the review and done the review. See, we have time to do that when you ask me, and when the review is over. Now, entonces, what is the idea? The idea is next Monday, we finish the review, I will send by email the test number 2. And this test is due next Wednesday, que es the day que es due. So you send me back the solution. Okay? You have to practice, guys. You have to practice. You need to work by yourself. Okay? Number 5. Number 5 is do the graph of the function f of x equal minus x squared plus 4. And find, they want to find y-intercept and x-intercept. Okay. Using transformation. I know very well that the function y equal x squared is a parabola. Like that. However, we have two transformations. We have this minus, okay, this minus indicates reflection. So this is x squared. However, when you are doing reflection like that, minus x squared is reflection. And plus 4 indicate vertical shift 4 units up. Okay, basically the graph look like that. At this point, it's super important, is 0, 0. Okay, 0, 0 here, because the only thing I did was flip it. Now it's plus 4, so it's 1, 2, 3, and 4. Okay? This graph is, this point now is a point 0, 4. And they want, can you find, or you try to find, the y-intercept. Remember, what is the formula for finding y-intercept always? It's evaluate the function and 0 using function notation. Entonces, minus 0 squared plus 4 is 4. And the point is a famous 0, 4. This is no surprise because we analyze this idea. Now, x-intercept. To find the x-intercept, the formula is different. You copy f of x and you enforce it to be 0. Entonces, like a minus x squared plus 4. And we have in that moment one quadratic equation, and this quadratic equation is super easy. We solve it by, I suppose, a square root method. No? For example, I copy that like that. Minus x squared plus 4 equals to 0. You isolate the x squared. The minus x squared is equal minus 4 divided by negative 1 both sides. X squared equals 4, and apply square root both sides. And this is x, and the answer is plus or minus 2. Remember, two solutions, when you take out square root, you have two solutions, plus or minus. So we have 2 points, que este point 2, 0 and minus 2, 0. Because I suppose the supposition was que the y is 0, look at that here. And the x value that I get is 2 and negative 2. Okay, by the way, it's that point. That point is 2, 0, and that point is negative 2, 0. Okay, end the story. Do the graph using transformation and compute the y-intercept and x-intercept. Any question? Super easy, super hard, super complicated? Easy. Okay, Katy Martinez. Okay, let's move on to number 6. Number 6 is similar. It's another function. This is a little bit more complicated. You have g of x is equal square root minus x plus 2. This is confusing because I know very well. Okay, they want using transformation to the graph of this. And by the way, we practice a little bit also y-intercept and x-intercept, que it's easy using the formula. Okay, I remember que square root function look like that. This is the classical square root function. This is a square root function. Now we can see two transformations. We have the minus here can indicate reflection and plus 2, but this is very, very confusing because when you see that situation, it's not clear. You manipulate like that. Look, minus x plus 2. This is a classical example. Not necessarily exactly the same plus 2. In the test, you see another number, no? For example, if you factor out this negative outside, we have x minus 2. This expression and this expression is perfectly equivalent. It's the same, no? Because you apply distributive property backward, it's negative x plus 2. So you see more clear now how the transformation perform. Okay, the first transformation is minus. The minus is reflection. And reflection is something like that. Look, reflection is something like that. Okay, reflect is across the y-axis. This is square root minus x. I did this minus first. Okay, this is the original, the basic square root function. And this is the same after reflection in that direction. We try to do best, reflection. And finally, minus 2. And you need to remember that when the operation is inside the parentheses, is horizontal shift. Is minus, entonces to the right 2 units. So the final answer is something like that. 1, 2, and that direction. This is the graph of this. So we perform transformation number 1 was reflection, and transformation number 2 is not clear. You need to manipulate a little bit algebraically the expression to see that sometimes happen it's not evident the transformation. You need to manipulate a little bit algebraically to understand much better. And I can see, wow, good. Reflection first, get this minus. And minus 2 indicate horizontal shift 2 units to the right. Because minus, I remember, is to the right. And positive is to the left. Okay? And this famous point, I suppose, get the point 2,0. At this point, I have no idea. But I want to determine now. Okay. Everyone follow me so far or no? Everyone follow me so far or no? Is it? Yes, okay, good. Now, I want to determine by curiosity Y-intercept, que es the function, evaluate en 0. Entonces, square root minus 0 plus 2. And this is square root 2. And square root 2 approximation in decimal is 1.41. Okay, I suppose it's this point. This point is a point 0,1.41. And the X-intercept is the function, and you enforce it to be 0. And you take the original, of course, no the transformer, no, the original. The original is the square root minus x plus 2 equals 0. And you have radical equation. You square both sides, minus x plus 2 disappear the radical, equals 0. I continue here, minus x is equal to minus 2. I bring 2 to the left, to the right, like a minus 2. Divided by negative 1, x is equal to 2. And this is no surprise. The point is the point 2,0. Exactly, we predict with transformation. Any question? No? No. Okay. Good. Let's move on to the question 7. I promise in the test you see one question, 7, in which you determine algebraically whether the given function are even or neither. Let me refresh your memory. Even is a function that when you perform reflection, look, I do reflection, replace x for negative x. The function, wow, amazing, stay the same. Doesn't change. It's odd when you are doing reflection again, we have opposite sign. Otherwise, and neither. Otherwise, cannot satisfy this condition. This is a special case. And this is not special. It's completely ordinary case. Okay, so now let's do it. Example 1, we are doing the question 7. Say k of x is equal 3x squared plus x to the 6th power plus absolute value x. As you replace x for negative x, okay, let's do it. 3 minus x squared plus minus x to the 6th power plus absolute value minus x. Okay, and you manipulate algebraically. You know very well that when the exponent is even, the negative quantity becomes positive. that this stay the same. This stay the same. The reason is because the exponent is even. That is the reason it's even function. An actual value negative number positive. And we compare the last equation and the original. In this case, is exactly the same. Therefore, the conclusion is it is even. Any question? Let's go to B. B, the name of the function is G, and G is x cubic plus x plus 1. To prove algebraically C is even, odd, or neither, you make a reflection. You replace x for negative x cubic plus negative x to the first power. The power here is 1 plus 1. Okay, entonces I know que cuando es even exponent, odd exponent, es negative 1 because negative x cubic, for example, in my mind, working like a minus 1 to the cubic power and x cubic, no? And negative 1 to the cubic power is negative 1. Entonces, negative, this is negative x cubic. And plus and minus is negative plus 1. And we compare this and this. It's exactly the same. It's the same. No. Entonces, no even. It's completely opposite signs. No, because this is positive, this is negative, positive. So stay. Therefore, the answer is neither. Okay. Recall again. Since X is identical, twin brother is even. Si it's completely opposite signs that you affected the entire expression by negative 1 is odd. Otherwise, is neither. In this case, no 100% opposite sign. Fail one sign. Therefore, it's neither. Everyone follow me, or you are totally lost? Do you understand or you don't understand? Clear or confusing? Come on, guys. Come on.
I don't understand why it give you minus x cubic.
Look at that. The reason is clear. Look at that. You replace x for negative x, and you manipulate a little bit this negative x cubic plus minus x plus 1. Okay, but I know this negative working like a negative 1, no? It's negative 1 cubic, the same exponent, and x cubic. Therefore, negative 1 cubic is negative 1 times negative 1 times negative 1. So we have 1, 2, 3 negative, so because negative 1, no? Because negative multiplied by negative is positive together, and positive and negative again is negative. This is negative 1, and this is a cube. And this is plus and minus, it's negative. And this is this plus. Got it? Got it?
Yes, thank you.
Okay. The most important is not this idea, is we compare the new expression after the reflection with the original. And you see, we have exactly the same signs or no? This and these are twin brother? No. Entonces no even. And this is totally opposite sign? No. Because this plus stay. Conclusion, neither. Okay? More clear now?
Yes.
Let's move on to the C question. C question is a little bit confusing. Look. C question is h of x is equal x cubic over x squared plus 1. But you need to understand this is a fraction. Numerator, denominator. Let's make a reflection. So to prove algebraically, if one function is neither O es odd, o es even, you make a reflection. So in other words, you replace x for negative x. Entonces the shortcut to understand super fast is when exponent is odd, it's negative. When exponent is even, it's positive. But the confusing part, exactly in this problem, is that this is a fraction. And a fraction, when you have numerator negative and denominator positive, you can write like that. You can write the minus and the top and the bottom and the front. And this is the moment to compare this expression and this expression. Entonces, ¿es the same o no? No. Entonces, ¿es completely opposite sign or no? What do you think? Is yes. What mean to be yes, Angelina? Is opposite sign, completely opposite sign? Absolutely. It's completely opposite sign. Because therefore the conclusion is this function is odd function. Because the final answer after the reflection have opposite sign to the original, because the original is supposed to get positive here. So I do not indicate it's positive, but before you understand it's positive. Okay, super. And let's do it one more. D. D is easy. P of x is equal x squared over x squared plus 4. Reflection, we are doing reflection now. Entonces minus x squared over minus x. Wait. This is 4 power. This is 4 power plus 4. Entonces I remember the shortcut. And when it's even, the exponent is positive. Wow. Entonces we go 4. I don't know why I put 2. I compare this and the original. They are twin brothers or no? Absolutely. This is even for me. Okay, this is the fantastic conclusion is you make a reflection. Reflection is algebraically change or replace x for negative x. You manipulate algebraic a little bit. If the function stays the same, it's identical, it's because it's even. See, the function completely opposite sign is odd. Otherwise, it's neither. Otherwise, it's a combination. Okay, one part change, another part no. Entonces, it's a mixing. Entonces, neither. No symmetric. Okay, let's move on to the question number 8. I suppose it's the last one for today. This is a little bit confusing. This is one graph is given. Let me try to do my best. This is 1. This is negative 1. Okay, this is 2. This look like parabola, like that. Okay, this is 2,4. This is 1, 2, 3, 4. Absolutely, yeah, 4. This is 2, this is 0, this is negative 1. So we have now the 4, 5, 6, and 6. We have open circle, and this is a constant function in that direction, and this is negative 1, and the y value. This is open, and this continues forever linear function, something like that. This is 2, this is 3, this is 4, this is 5. This is a piecewise function, but given no in the classical algebraic ways, graphically. And you need to evaluate several. Evaluate 4, evaluate negative 2, evaluate positive 2, evaluate 0, okay, evaluate wow, and negative 1. In the test, not too much, but okay, we practice, no? Evaluate negative 4, evaluate negative 5, evaluate positive 5, 6 and 7. Wow. Okay, let's do it. It's easy. 6 and 7. Okay, let me start for the first. In 4. That means x is 4. 4 here. X equal 4 here. That position. And you go in order to find the y value. Remember the function notation is y is equal to f of x. In other words, the thing I asked you is what is the y value associated with the 4? X equal 4. So you try to go to the graph and touch the graph. I don't know. Si I go down or up. Angelina Melu. 0. No, 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 no 0, no 0, no 0, no 0. No, no, no. It's 6. Okay, okay. I go x equal 4. X equal 4. I go to the graph. I don't know if we have graph upward or downward, but I try to touch the graph. Yeah, I try to find the y value. This point is the point 4,6. Now the y value associated with the 4 is 6. Do you see or no? A negative 2. So now, some value in the test, you need to use a little bit imagination because you need to extra ball. Suppose negative 2. Well, negative 2 is located here. Negative 2. And negative 2, I go to the graph, touch the graph here. I suppose that this is a linear. If it's linear, this is a line, is negative 2. Negative 2. So you need to use your imagination. Maybe the answer is not exactly the same, but it's approximate, it's close. So I accept this answer. 2 positive. Now, 2 positive is confusing. Because in 2, x equal 2, here, x equal 2, I go to the graph, but I have a circle here, close, and circle open here. What you take, the open or the close? What mean to be close? What mean to be open? Open is here, it's undefined, no value. And close is defined. Defined to the value is, in my opinion, 4 here. The answer is 4. Do you understand this or no? 0. Oh, 0 is 0. Negative 1. Oh, no, negative 1. Oh, be careful. Negative 1, I'm moving up or I'm moving down? What do you think? This is confusing. I'm moving up. I'm moving up because, I suppose that this is 2. Because we have here a circle close and the circle open. And open is undefined. Okay. So say negative 4, negative 3, negative 4. It's obvious que es negative 4. It's easy. And negative 5, well, negative 5. It's linear. And 5 positive, it's a constant function that stays forever and the same height. It's 6. 6, 6. End the story. And 6 and 7. Do you understand or no? Confusing? Very, very confusing or very, very clear? Come on, guys, let me know. Understood. Very well. Okay, okay. Okay, determine domain number 10. It's a number, that was number, what number it was? Number 8. Because I skipped, it's in the packet, I put number 10. Wow, I'm crazy. Okay. Let me try to explain number 10. Que actually number 10 is not number 10, it's number 9, but well, it's okay. Okay, this is one in the test, I promise. Okay, one graph is given. I don't know if it's exactly the same of this or not. One graph is given. Let me try to do my best. 1, 2, 3. This is 1, this is 2, this is 3. This is 3. 2, 3. Approximately. I try to do my best. This is open. And in 2, it's close. It's going down. It's decreasing. But this is not the point. They want to determine domain, and range of that function. Look in the graph. Only look in the graph. No mathematics, no nothing. Look in the graph. So remember, domain is the set of the x value. It's a set of x value. Such that the function is defined. The function is defined. Function is defined. As if the function is undefined, undefined is, for example, in the circle open, it's undefined. No? We have in between 2 and 3 one gap. So basically, the domain of this function is from negative infinity to 2. Don't include 2. Okay, remember, you're projecting any point on the curve, projecting onto the x-axis because it's domain. Likewise, this is a bracket here to infinity. It's a minus infinity, it's a positive infinity. So the domain actually is, okay, is parenthesis minus infinity, comma 2, parenthesis, because in 2 is undefined, union, bracket, 3, comma, infinity. This is the domain. Do you understand this or no? Yes or no? Answer me. Yes or no? Okay. Okay, guys, stop. Because I promise next Monday we continue doing number 10. I repeat again the idea for number 10. And we are completed with the range, you know. Important. How I suppose you are studying, doing the homework online. Hey, Alex, we have plenty example of this. Anything you don't understand, you can email me or the tutors, que is available anytime. Anytime, no, pero the majority of the time in the online, you can available for you. Okay? Okay, super. Thank you so much for your attention. Okay. Try.